Oh, by the way, there was a handout before class, but I apologize because it was only posted a little bit late. So yeah, I'm sorry about that. I still would encourage you all to read it. It would be a really good complement to what we're going to go over in this class. By the way, as always, please let me know if I'm going a little bit too fast or too slow for your liking. Okay. So it's around 5 o'clock now, so we'll start. Okay. First question, the next one. So, oh, by the way, just a quick poll. How many of you know about Vieta's formulas? Like just type yes or something in the chat. Yes. Okay, awesome. So in that case, I'll give you all maybe like 1 minute or 2 minutes to attempt this question. And if you have the right answer, please DM hosts and panelists. And please just message us. And by the way, if you like don't know what Vieta's formulas are, like please feel free to like speak up and I can explain them. And I will probably explain them after this. Okay. Okay, sure. We'll go over Vieta's first before attempting the question. So basically, there's a nice explanation of that in the handout. So let's say you have some polynomial. Well, let's just start off with a quadratic. X squared minus plus. Let's start out with a quadratic. Ax squared plus bx plus c equal to 0. So because this degree is 2, there are 2 possible roots of this equation. Roots are basically like solutions to it. So there's this really nice theorem of algebra which states that if a polynomial starts with like ax to the like 17 or something, then it'll have some 17 roots. As long as this is the biggest number in the polynomial. So it sometimes can be a real pain to actually calculate the roots themselves. But Vieta's allows us to take interesting things with roots a little bit differently. For example, in our quadratic, like there are 2 values here that will make this equal to 0. Let's say r and s. So we know ar squared plus br plus c is equal to 0. What Vieta states is that r plus s is equal to negative b over a, and r times s is equal to c over a, where a, b, and c are these coefficients right here. Yeah. So, but the thing is with Vieta's, we can generalize this to bigger polynomial. So let's take this one, this really big one. Basically, here's how it's going to go. The first term is just a 1 here. So I can say, and because this is a 6, this will have 6 roots. I know that the sum of all of these 6 roots will be negative, whatever this term is, divided by 1, or negative 10 over 1, which is just equal to 10. So you might be wondering, well, is the product of all the roots going to be just this a over 1 then? Well, okay. When you say product of the roots, it's more like summing the roots, but taking up them multiplied 2 at a time. So the first summation is just like R plus S plus T. And the second thing will be RS plus ST plus RT. And only the third thing will be RST. So basically, if this was a cubic, this would be this would be equal to negative B over A. This would be equal to C over A, and this would be equal to D over A. So here, we know that this over that is equal to the sum of the roots. This A is equal to the sum of the roots, but taking 2 at a time. So basically RS plus ST plus RT for all 6 roots. This B, which we basically need to calculate, we know that negative B divided by 1 is equal to the product of the roots taken 3 at a time. Or let's say the roots were A, B, C, D, E, F. It would be ABC plus ABD plus ABE plus basically any possible combination you can think of which has 3 numbers. So what are we given? Well, we see this 16 here. That's an actual number, so we can use that to calculate something. Well, this will be negative, positive, negative, positive, negative, positive. So you can say the product of the roots taken 6 at a time, which is basically just the product of all the roots, is going to be 16 over 1, which is 16. So now we have reduced the problem to 6 numbers, which are the roots. They're given to us as integers. And then we know their sum is 10, and their product is 16. So there are ways to legitimately solve this, but like probably the best way is factor out 16 and see what we can find. Well, 16 is just 2 to the power of 4. And okay, so I need 6 integers such that their sum will be equal to 10, and the product is this. Well, it's our lucky day because this 2 to the 4th is just 2 multiplied by itself 4 times 2 ones, and this sums up to 10. Sorry, the sum is equal to 10. So basically, what we have to do now, we need to find out what the B value is. And as I said, the B value is the product of the roots taken 3 at a time. And it's not only that, it's negative B is equal to that. Sorry. So basically we find that negative B will be equal to 2 times 2 times 2. And there are basically 4 ways you can have this because there are 4 of here. Then let's say how many 3-way products have 1 of these ones in it. Well, of course, there are 2 choices for the ones, and then we have to pick 2 out of these 2's to multiply. So that's 6. It'll have a product of 4. So we have this. Yeah, that's fine. And then just the products with just 2 ones, or there are only 4 ways to do this because there are only 4 2's, and this will be 2 each. So if we add this up, this is 32, this is 48, and this is 8. So we find that negative B is equal to 88. So B is equal to negative 88, which is answer choice A. So, I know I went a little bit fast, but do you all have any questions? If you do, please speak up. Wait, hello, can you hear me? If so, could you write something like yes in the chat? Oh, okay, awesome. So basically, like, do you have any questions about what we have here? You can just write no if you don't. Okay, awesome. So now we'll go on to the next question. This question is a good bit harder. So please take some time to read over it and just put into chat or use the question feature for any ideas you may have. Like, how do you think we should start on this problem? Oh, okay. So this line on top of the P, this line on top of the P is basically just like another name. So like, it's just fancy notation. It's basically saying that, okay, this polynomial, so we have some, you might as well just call it like an f of x. It's basically saying that f of x has this property, and out of all the possible polynomials that have this property, it has its sum of the roots maximized. Like, does that answer your question? Okay. So I've given you guys a little bit of time to read over it. Now let's work through the problem. So let's look at the first condition we have. P of P of X equal to 0. And it says there are only 3 real numbers that solve this. So this is an instant red flag. You know that there are 2 solutions to any quadratic. Let's call them, for this P of X, as R and S. So basically P of R is 0 and P of S is equal to 0. What that means is that because these two are the only possible solutions, this inside value of P of X must equal R or equal S. So P of X is equal to R or S. So in the case that P of X is equal to R, let's say there were 2 solutions. But that means in the case that P of X was equal to S, there's only 1 solution. So as discussed last time, there's only 1 spot on a quadratic when you graph it. So you only have 1 solution. It's this point right here. Because otherwise you're just going to have 0 solutions or 2 solutions. Does anyone remember what this point was called? Yes. Oh, by the way, don't worry about the raise hand thing. Just put your answer in the chat. Hey, yeah, awesome. Good job. Yeah, good job, Aditi. So basically, we have this point called the vertex. So because vertex is a really important point in this problem, let's use vertex form for the parabola. You can call P of X as a x minus h squared plus k. Awesome. And something we know here, because this particular value s only has one solution, this k here must be equal to s, because that's s is the y coordinate of the vertex. So now we know p of x is equal to a x minus h squared plus s. Awesome. Something else we know, because it has a leading coefficient 1, this a is just a 1. So you can get rid of it and just write 1. Does everyone understand how we got here? If you do, just please write yes in the chat. So like, are you guys just lost or are you just not responding? Well, so if you understood how you got to here, yeah, write yes in the chat. If not, like, I'm always totally fine with going back over. Okay, yes, awesome. So now we know that this has two roots, r and s. So where can we go from here? Well, we know that p of s is equal to 0, so you might as well start there. So if we expand this out, we'll get that s and plug in x as s. We'll find that s squared minus 2h minus 1 times s plus h squared is equal to p of s, which is just 0. Awesome. So if we expand this even more, we'll get that 2h squared, sorry, 2h minus 1 squared minus 4h squared. Oh, sorry, is greater than. Okay. So basically, we know that there must exist two distinct roots for this, because of course, yeah. So we know that the discriminant of this thing must always be greater than, must be greater than 0. So what's the discriminant? Well, if we have quadratic ax squared plus bx plus c, we can call something called the discriminant, which we sometimes call delta, is equal to b squared minus 4ac. You might notice this as in the quadratic formula, it's basically negative b plus or minus this discriminant over 2a. So something we know, because we can't square root a negative number, and if it's 0, then plus 0 and negative 0 are equal. Only if the discriminant is greater than or equal, is greater than 0, we can have two distinct roots, as we have. So because, we already have one, we already plugged in one root for s. So because 2h minus 1 squared minus 4h squared is greater than or equal to 0, we can simplify this and find out that h is less than or equal to 1/4. Okay. So does everyone understand how we got to this point? That h is less than, that h must be less than or equal to 1/4. And if you have like any questions at all, I'm totally fine with. Just put it into the question analysis. Okay, awesome. We'll move on. Oh, to the original problem? Sure. Here's the original problem. Is there any part about the original problem that you would actually like me to go over, or it was just like you needed to see it? I just need to see. Awesome. Okay. So now we know that h is less than or equal to 1/4. Well, something we know, because we just did VRS formulas, we know that r plus s is equal to 2h. So basically, because we wanted to maximize the sum of the roots, we basically need to maximize what this h is. So obviously, the sum of the roots is maximized when this h value is maximized, or when h is equal to 1/4. So basically now, all we have to do is just go back and plug it in. So, we can find out because this p of x is maximal, we know that p of x is equal to x minus 1/4 squared minus 1. So we know that this had to be because this was the h value, but if we just plug it in, because we knew that this had to hold true, we can easily plug this in back to our original equation here and solve for s, which comes out to be negative 1/4. So now we have the actual polynomial itself. All I need to do is find p of 1. So if we plug 1 into this, actually, yeah, I'll let you guys do it. Finish up the question. If we plug p equals 1 into this, what do we get? If you have the answer, just private messages. Okay, but do you all understand how we got here and what we need to do? If so, just write yes in the chat, or better yet, try and we know the polynomial. All I have to do is plug in x equals 1 into it. What do you get? Yeah, that's right. Good job, Karen. It is a. So basically, 1 minus 1/4 is 3/4. And 3/4 squared minus 1/4 is equal to 9/16 minus 4/16, which is 5/16, or A. Okay, awesome. That was a pretty challenging problem. So like, don't feel scared or anything if you have questions. Or if you just want me to go back to something, that's totally fine as well. If not, then we have a new type of question, a graphing question. So I'll give you all a little bit of time to work on this question. At least to read it. Oh, also, just take some wild guesses. Like, what do you think? What shapes do you think we might see in this region? Like, what shapes do you think this would look like? Just well, some names like rectangle, square, circles. What do you think you're going to find here? Yeah, that's nice. Good job, Aditi. So basically, we're going to be finding, yeah. So a lot of you noticed that this is almost exactly the equation of a circle. The only thing is that we have some interesting things going on the other side. So how are we going to deal with this? Well, we have absolute values. The best way to deal with absolute values is to use casework. So let's just take the really easy case. Let's say that x minus y was greater than 0, and x plus y was also greater than or equal to 0. Basically, all this means is that y is less than or equal to x, but y is also greater than or equal to negative x. So let's plot the region that we can possibly discuss here. Well, if y is greater than or equal to negative x, wait, what did I do? Oh, yeah, nice job, Lily. That's exactly what it's going to be like. Yeah. So let's think about what region we're going to be looking at here. Okay, so we know that x plus y is greater than or equal to 0. So basically, x plus y, here this line will be greater than or equal to 0. So on this side of this line. But then we also know that y is less than or equal to x. So we're on this side of the line, y equals x. So basically, we're doing stuff in this area, and because it's symmetric, we can easily reflect it to other areas. So basically, what does this simplify to? Well, now we know x squared plus y squared is equal to 6x in this area, or x minus 3 squared plus y squared is equal to 9. So this we know is just a circle centered here at the point 3, 0 with radius 3. So it would look a little bit like that. Does everyone understand where we got that from? Like, if you do understand, please write yes in the chat. If you don't, just use the question, just use the Q&A feature. Okay, awesome. So basically, now we've got here, right? What are we going to do from here? Well, it's going to be a symmetric figure. So it's sort of like we have a circle here, a circle here, a circle here, and a circle here. Oh. Circle here. And they all have the exact same radius. Oh no. So basically, this is what our graph would look like. And the area we want to find is this colored in area over here. So well, how are we going to find that? Well, as you can see by the diagram, it looks a little bit like we have a square. Sorry. And then we have a bunch of semicircles on the side of that square. So now this is a lot easier to calculate the area of. It's the square. Well, the square. Because the radius of the circle was 3, we know that this length here is 6, and this length here is also 6. So the area of the square is 36. And then these semicircles are a little bit like two big circles. And the big circles had radius 3. So the area of one of these big circles is 9 pi. So the area of two of these will be 18 pi. So our answer will be 36 plus 18 pi is the area of this region. Which turns out, oh, they want the sum m plus n. So it's 36 plus 18, or 54. Does anyone have any questions about how we got there? Or like the motivation behind the question or anything like that? Okay, awesome. So this question really illustrates a good approach that we should always have to these graphing problems, and that is basically to graph them. Just take cases, do whatever you need to do so that you can actually make a picture of the graph. Like there's almost no way that you guys are, well, it's going to be pretty difficult at least to find out the area of the graph without actually graphing it. And visualization is always a good way to do things. Anyway, now we have this problem. So there are two solutions that we have for this problem. And yeah. So first, let's look at this condition. We know that x plus 1 over x is equal to square root of 5. So we wonder, x plus 1 over x squared is equal to 5. But what do we get when we expand this out, this x plus 1 over x? If you have the answer, please use the Q&A or the chat to answer. Okay, I see a few right answers. Does anyone else want to try? Don't worry, it's totally fine even if you submit a wrong answer. And if you don't understand what's going on, please feel free to ask at all times. Yeah, that's right. Awesome. Okay, so now we find that this will simplify to x squared plus 2 times x times 1 over x plus 1 over x squared. And this is equal to 5. The cool thing about this is that x and 1 over x will cancel. So x squared plus 1 over x squared is equal to 5 minus 2, which is just 3. If we do this again, we can find that x to the 4 plus 1 over x to the 4 is equal to 7. So now from here, there's a really nice, or not so nice, but there's a trick way to end the problem. If we multiply everything here by x to the power of 7, we find that x to the power of 11 plus x cubed is equal times 7 x to the power of 7. So x to 11 minus 7 x to the power of 7 x cubed is equal to 0. And this is exactly what they wanted to do. So does everyone understand how we got that? Because we'll be approaching it with a more general way a little bit later. And if you don't understand any part of that solution, please speak up. Okay, awesome. So now a quick poll. How many of you have heard of, the last part quickly? Awesome. So by last part, do you understand how we got to here? Do you understand how we got to this part? Yes? Oh, okay. Wait, mostly? Wait, what part? Okay, sure. How we got to there? Okay, awesome. So we know that x plus 1 over x is equal to root 5. We squared both sides of the equation and found that this is equal to 5 over x squared plus 2 plus 1 over x squared equals 5 over x squared plus 1 over x squared equals 3. So we can do the exact same thing all over again, where x squared plus 1 over x squared is equal to 3. So if we square all of this, we'll find x to the 4 plus 2 times x squared times 1 over x squared plus 1 over x to the 4 is equal to 9. Again, these cancel. So we find that x to the power of 4 plus 1 over x to the power of 4 is equal to 9 minus 2, which is 7. So that's how we got to this part. Now, we can finish the problem by, well, we know that this is equal to 7, right? Let's multiply both sides of this equation by x to the power of 7. Okay, so this is what we find. But this just means that x to the power of 11 plus x cubed minus 7x to the power of 7 is equal to 0. But this is exactly what they asked for here. Therefore, the answer here is just 0. Do you have any further questions, or do you want me to go over any part of that again? Wait, so do you all understand how we got there? Awesome. Yeah, feel free to ask questions. Questions really help all of us figure out what we need to help out with. Awesome. But, you know, that method is a little bit interesting. If we just squared some magical things and then multiplied by x to the power of 7 for some reason, then we got somehow a magical answer. How could we do it for just some normal thing? Well, here's a nice formula that is coming up a lot more in AMC contests. It's called, or at least it's more of a technique called Newton's sums. Just a quick poll, how many of you have heard of Newton's sums before? If you have, write yes in the chat. If you haven't, write no, please. Okay, a few no's, a few yeses. Okay, I'll explain it again. So, okay, we have a polynomial. Okay, so we here know that x plus 1 over x. Okay, let's start with a simpler polynomial. Let's say that x squared plus ax plus b was equal to 0. Awesome, nice polynomial here. Now let's say its roots are r and s. So now we know that r squared plus ar plus b is equal to 0, and s squared plus as plus s. Oh, no, sorry, plus b is equal to 0. Okay, so what we can do here, because this is 0, we can multiply by this by r to the power of n, and nothing will change at all, except we need to multiply both sides by it. What we get when we multiply this is that r to the power of 2 plus n plus a times r to the power of 1 plus n plus b to the power of times b plus b times r to the n is equal to 0, and s to the 2 plus n plus a times s to the 1 plus n plus b times s to the n is equal to 0. So what happens when we add this up? Well, just add both of these, and you find that r to the 2 plus n plus s to the 2 plus n, sorry, to the, sure, same thing, plus a times r to the n plus 1, so s to the n plus 1, plus b times r to the n plus s to the n is equal to 0. So now, just to make writing a little bit easier, let's say you want to calculate like r to the 8 plus s to the 8. Well, a really nice and simple way to write this, let's just introduce some notation. Let's call this P8, where basically P8 is r to the 8 plus s to the 8. And let's call P7 as something like r to the 7 plus s to the 7. P2 would be r squared plus s squared, and so on. So like, does everyone understand how we got to this part and what this P thing means? If so, please write yes or no in the chat. I can definitely go over any part of it. If you do understand what this P means, then what's another way to write this circle thing? Okay, yeah, nice. So basically, this circle thing is basically just saying that P of n plus 2 plus a times p to the n plus 1 plus b is equal to 0. So basically, this is basically what Newton's sums is all about. Instead of calling something x squared, x1, x0, we can replace it as like p to the n plus 2, p to the n plus 1, p to the n plus 0. And basically, it'll still be totally true for any value of n. So really, what does that mean here? Well, we know here that x plus 1 over x is root 5. So, well, the thing is, if x satisfies this, then 1 over x also satisfies it, because it's literally just the same thing. So let's say we knew for certain that this was true. And then if we instead plugged in x as 1 over a, we know that this would be the result. And this is just equal to 1 over a plus 8, which is just root 5 all over again. So basically, the roots to this equation are reciprocals of each other. So now what we can do from there, we can sort of game the question a little bit. So because we were looking for this value, obviously, it must be the same for both values. Otherwise, they would say, what is the greatest possible value of this, or the least possible? So we can just rewrite it as, oh, by the way, does anyone still need this slide? Please write like, yes, you still want to look at the slide, or you don't. Okay, awesome. So basically, we can rewrite this as what we want as half of x to the 11 plus 1 over x to the 11 minus 7 x to the 7 plus 1 over x to the 7 plus x cubed plus 1 over x cubed. So now the question has just become, find this value. And how are we going to do that? Well, we said x and 1 over x are the roots, right? So, well, we already know x plus 1 over x, which is just going to be what P1 is all about. And then, you know, x squared plus 1 over x squared, which is just P2. Awesome. Let's plug it in. So remember, this is true. And if we simplify this, we'll get that x plus 1 over x is root 5. So x squared plus 1 is equal to x times root 5. X squared minus root 5x plus 1 is equal to 0. So basically here, a is negative root 5 and b is 1. So we can say that p of n is equal to root 5 times p of n minus 1 minus p of n minus 2. And the good thing here, we know what p of 1 is. This was given to us as root 5. And we know p of 2 because we just calculated that. And what this question is asking for is now half of p11 minus 7 p7 plus p3. So all we have to do is just calculate this. So now we know p3, if we use the formula right here, is the square root of 5 times p, what is 3 minus 1? 2. p2 is just 3, sorry, times root 5. And then pn minus 2 is just this value, because 3 minus 2 is 1. So we need to subtract root 5 from this. So p3 is 2 root 5. Continuing the pattern, p4 is the square root of 5 times 2 root 5, which is this value. Whoa. Oh, sorry. And then all I have to do now is subtract the two values ago, which was 3. So we find P4 is 7. Well, that's awesome because we already calculated P4 to be 7 right here. Yeah, that's precisely what we calculated here. But now we need to go all the way up to P11. So just to check if you all understand, what's P5? Like how do we calculate P5? If you know the answer, please use the chat. If you don't know the answer, just tell me so via the Q&A, and I can explain how we get that. Yeah, that's right. Good job. I'll give you some time to work on. Oh, by the way, just use the chat. Are any of you like lost right now? Do you want me to go over anything? Because I'm totally fine with doing that. Like if you want me to go over something, just like put it in the chat. If you're fine, then just write no in the chat. Oh, yeah. Yeah, that's right. Good job. Okay. Yeah, seems like a bunch of you are giving responses. Okay, I think a bunch of you are actually on the right track, so good job. So basically how you find P5 is you use this formula. P5 is the square root of 5 times P4 minus Pn minus 2, or P3. Oh yeah, that's right, good job. So P4 is 7, so we can plug that in here. And P3 is 2 root 5. So you plug that in here, and you get 5 root 5. So all you have to do is just keep plugging this in for a good little while. Yeah, 5 root 5, nice, good job. Good job too. So now all you have to do is keep plugging this in up till P7 and P11. So if we plug this in up till P7, we find that P7 is equal to 13 root 5. And then if we plug this in all the way up till P11, we find P11 to be 89 root 5. Then all we have to do is plug it into this formula. So all we want is 1/2 89 root 5 minus 7 times 13 root 5. Sorry, that's a 5. Is 91 root 5 plus 2 root 5. And that turns out to be 0 again. So that's another interesting method that we can use to solve this problem. And that method's becoming a lot more required, like a lot more. So that's nice. Does anyone have any questions? I know this topic can be very much confusing at first. Not that I'll be moving on to some. Oh, we'll probably move on to this question. Oh, by the way, do you guys have questions? Just write yes or no in the chat. Like, yes, you have questions, or no, you don't have questions. No? Okay, awesome. Awesome. Nice. Now let's try this question. So this question, sorry for the lack of centering, but if you want to find how many positive integers n satisfy this. Okay, well, this part of the equation looks pretty nice. And this part of the equation looks very not nice. We have both a floor function and a square root. So, just quickly, do all of you know what the floor function does? And if so, what's the floor of the square root of 17? Like, if you know, please type the answer for this into the chat, or haven't learned it yet? Okay. Yes, yep, that's right. Nice. Okay, so floor just means integer below. You can think of it like that. Yeah, that's right. So let's say this was a number line here. So this is 1, 2, 3, 4, 5. So we know that the square root of 17 is between 4 and 5. Let's say it's like here somewhere. What floor function means is that start here and then start going left. The first integer you find, in this case 4, will be your answer. Basically, when you take the floor of some number a, if this number a was like some 8.3765 whatnot, all you have to do is get rid of all this decimal point stuff and just report the integer. Yeah, that's right. That's right. And that's also right. Nice job. So now we need to solve this equation. And this looks pretty scary. So how are we going to do this? Yes. Basically, floor of negative 4.5 is equal to negative 5. Because if we number line again, say this in negative 3, negative 4, negative 5, negative root 17 would have been here. Or sorry, negative 4.5 would be here. So if we start here and then go left, the first integer we find is negative 5. So that's our answer. Does that make sense for everyone? Okay. But we don't need negative numbers here. Oh yes, for this thing, it basically only works with positive numbers. With negative numbers, you can just write it as negative 9 plus something. So now what we have to do is we need to solve this equation with floors. So it's really, really annoying to actually have to work with floor functions. So let's just substitute root n as a plus an ugly decimal. Or better, let's say n is equal to a squared plus some number b. Well, we know that we know that b must be less than 2a plus 1. If it was equal to 2a plus 1, then root n would just be 8 plus 1. And then the integer part of this would not be a anymore. So therefore, we can start our question by saying, okay, n is equal to a squared plus b, and we have a bound on b. Awesome. So where are we going to go from here? Let's plug it into the equation. So we know a squared plus b plus 1000 all over 70 is equal to 8. That's just what the floor of n, root n, will be. So if we solve this, we get a squared minus 70a plus b plus 1000 is equal to, 1225. Sorry, what am I doing? This is 0. So if we factor this, we get a minus 35 squared plus b is equal to 225. So we need to find how many solutions there are to this equation. So first, can anyone just right off just tell me any solution? Just any solution that you immediately see. Just think about the case when b is equal to 0. Yeah, that's right. Good job. Can you think of another one? Because remember, there are actually two possible values of a, such that a minus 35 squared is equal to 0. Sorry, it's equal to 15 squared. Yeah, a is 20. Nice. Right off the bat, we have two solutions, 20 and 50. All other solutions need to be within this range. Because if you go out of it, then this a squared is already too big. But even though because the b cannot be negative. So basically, we need to try the range around here and see if we can get a b that works. So for 21, yep, that works fine. Because if we plug this in, then we'll find that b needs to be 29. And yep, that's totally fine. Because 29 is less than 2 times 21 plus 1, which was 43. This is definitely true. Well, let's try 22. And then that's here, a 13 squared. So 225 minus 169, which is 56. So basically we need 2 times 22, this 56, to be less than 2 times 22 plus 1. Oh, what does the b value represent again? Okay, so we just said that n is equal to a squared plus b, where a squared is the square that's just the least from n. So basically, the reason we did this was so that the floor of the square root of n would be a. So just b is just, yeah, a part of this formula. So, and we know b must satisfy this. So when we say 56 needs to be less than 2 times 22 plus 1, which is 45, this is definitely not true. So 22 is not a solution. So then if we just try going backward from 50, we find 47, 48, and 49 also work. So we have a total of 6 solutions here, which is answer choice C. Does anyone have any questions about how we got that? Does anyone have any questions about how we got that? If so, please use the Q&A. Okay, looks like there aren't that many questions left. So I'll give the floor to the debate people. Okay, have fun everyone, bye. Oh, by the way, please do the homework this time, because last time nobody did the homework and that's sad. Okay, bye. And make sure to submit with a Google form as well.